Okay, class, for this lecture, sorry I couldn't be here today, but you should be just fine without me here. This is actually a pretty easy one to go through. So what you want in front of you is you want a periodic table that you can write in. There is one in your packets. Do not use the one in your packet. The one in your packet is actually your assignment for after this lecture here. Okay, so don't write on the one in your packet. You'll mess it up, okay, and have too much stuff on there. Save it, write on the one that you were using in class on Monday, or if you've lost that already, okay, get another one. You want to try and hold on to the same periodic table as much as possible, because over the course, especially this semester, we're going to be writing things on it that are useful for you when you do your work. So this lecture today is going to talk about how the periodic table was organized, being able to classify things as metals, nonmetals, and semimetals, figure out a few distinguishing characteristics between the metals, nonmetals, and semimetals, name some of the groups and families and periods and be able to tell the difference between them, okay? So even though it's kind of a short one-page lecture, there's a lot of information on here. And if I go too fast, I apologize. Mr. Lopez or whoever is substituting my class today can always pause the lecture and back up if I miss something or I go too quickly for you guys. Okay, so Mendeleev is the father of the modern periodic table. Up until this point, they only had lists of elements because they didn't have that many elements. This is Mendeleev's first periodic table, and you can see there were not a lot of elements there. And so he was the first to arrange the periodic table, and he arranged it in terms of increasing mass. Okay? And things with similar properties were side by side. Now, these lines were things that he hadn't quite figured out yet, and these ekas right here represent things that he was predicting but wasn't 100% sure about at this point. And you can see he's organized his periodic table based on how they reacted with oxygen, so their reaction with the oxide. The modern periodic table is structured a little bit differently, okay? Moseley is credited for structuring the modern periodic table, and he is known for organizing it based on the number of protons. So we talked about on Monday how the periodic table, the number on top represents the number of protons. So you can say that, you know, the periodic table is arranged by number of protons, or you can say it's by atomic number. Now, you may think it goes up by mass all the time, but it doesn't. There are a few places on the periodic table where it doesn't go up by mass, even though you're increasing the number of protons. So, for example, if you take a look at, I believe it's cobalt and nickel. Okay, cobalt and nickel are side by side, right there in the middle of the periodic table. And even though one has more protons than the other, the mass goes down. Okay, so cobalt has 27 protons and nickel has 28 protons, okay? And then you can see at the bottom the masses actually decrease. So cobalt weighs more than nickel, okay? So, and part of this has to do with those isotopes. And I know a lot of you had questions about isotopes, and we're going to keep talking more about them so that they're less confusing to you. Now, cobalt and nickel is not the only place where the atomic mass gets smaller, even though the protons go up. So at this point, I'd like you guys to pause this lecture and take a look at your periodic table and see if you can find more places where the atomic number goes up, but the mass goes down. So there's a number of different spots where you can see it. A lot of them are down at the bottom of the periodic table. There's another one between tellurium and iodine. Okay. Between uranium and neptunium, Np, side by side. Uranium's mass is higher than neptunium, and I want to say there's actually like 5 or 6 different places on the periodic table where the atomic number goes up and the mass goes down. So it's really important to know that the periodic table is arranged by protons. Now, how it gets its funny shape, that's something more we're going to talk about in Unit 3. Okay, so states of matter at room temperature. If my periodic table is not pulled down right now, why don't Mr. Lopez or my substitute go ahead and pull down the periodic table so it'll be a little easier to highlight some of these things. So here on the one I'm showing you on the screen, there are 2 elements that are liquid at room temperature. So they are mercury and bromine right here. Okay, I got them circled on this video. All the ones that are written in black on my periodic table hanging in the classroom or here in purple, they are liquid or solids, solids at room temperature. So over here with the key, you can see they are solids at room temperature. And this ink color is just not working. Let's try blue. Okay, so solids. So most of the periodic table at room temperature is considered to be a solid. There's 2 liquids, and then we've got a couple of gases. And I believe on my periodic table in the classroom, actually, you know what? I'm not even going to guess. I don't remember what color they are. But you can see how they match there. So just a few gases at room temperature. Okay. Here's a line you should be writing in your notes. Metals are good conductors, have high luster, they're ductile and malleable. So we're talking about good conductors of electricity. So that's what conductor means. It can conduct electricity. Luster means it is shiny. Okay. Ductile means you can draw it into wires. And malleable means you can bend it into shapes, like a paper clip. Okay, so metals are good conductors of electricity. They have high luster, they're shiny, they're ductile, and they're malleable. And again, you can see most of the periodic table are composed of metals. Now, one thing I do want to point out is hydrogen. Now, this periodic table puts hydrogen in the middle. And part of the reason why they do that is because I told you guys the other day that hydrogen is weird. Okay? Hydrogen does some weird things. And so some periodic tables like to avoid the controversy and just put it in the middle. Now, your defining thing, the way to help you tell metals from non-metals is that stair step on your periodic table. You'll notice you've got this stair step going down your periodic table, and that's what helps you tell the metals from the semi-metals. Okay, so your metals are everything to the left of that stair step with the exception of hydrogen. So again, watch out for hydrogen. Your non-metals are found to the right of that stair step. So again, this up here, okay, should be written in your notes. At room temperature, most are gases. They are poor conductors of electricity, and they are brittle. Now, hydrogen is included in the non-metals. Okay, so some people say, well, hydrogen should go on the right-hand side of the periodic table. But we're going to see again later why it gets included on the left-hand side. Okay, so, you know, there's reasons for each. And again, that stair step line is going to help you tell things to the right of the stair step are your non-metals plus hydrogen. Okay, so that's what you want to watch for. Now, things that touch the stair step are called metalloids or semi-metals. I honestly really don't care which term you use. There's semi-metals right here, and there's metalloids. Okay, Most people these days tend to use the word semimetals. Now, metalloids have properties similar to metals and nonmetals, so they do a little bit of both. And you can see your metalloids will touch that stair step right here. And in fact, let me see. Do I have that stair step drawn in? I do not. Okay, so here's that stair step. So all these green ones are considered semimetals, but notice there's one of them touching the stair step that is not a semimetal. Okay, and the one exception is aluminum. Everything else that touches the flat part of the stair step is a semimetal. And the one thing I tell you guys to help you remember is remember aluminum cans. Okay, aluminum cans are shiny metal or like aluminum foil. Okay, so aluminum is the one exception to touching the stair step. That one's considered a metal. Now, you have 7 periods on the periodic table, and remember they're arranged by increasing atomic number. So periods go from left to right, and vice versa. So those are your periods. These 2 rows at the bottom go up in here. Okay, so you can see on this periodic table, the bottom row I go 87, 88, 89, 90. I go all the way across to 103, and then it comes right back up here to 104. Okay, why do they do that? Why are there 2 rows at the bottom of the periodic table? Again, you're just going to have to wait and see. You'll get a little bit of the hint today when I talk about group names. You really won't get the why till Unit 3. Unfortunately, here right in the beginning, there's some of those, oh, you have to just wait. We're going to get to it. Okay. All right, vertical columns are called groups or families, and they are identified by a letter number combination. Okay, so here at the top, okay, letter number combination 1A or group number 1. Okay, 2A, down here are B's, and then back here are A's again. Okay, or they're just numbered 1 through 18. So what happened was the old way was like these Roman numerals with letters A and B. The new way is, you know, screw it, let's just number them 1 through 18. Now, they are arranged by chemical properties. So what happens is the reason why they're called families is because maybe they all look the same or they all behave the same. So like all these guys here, drop them in water, they explode. Okay, so we'll talk more about that, but that's just the terminology. They're called families or groups, and you really should know both terms. Okay, your representative elements. So your representative elements are anything that is what I call the mountains. So here, this would be, or a peak. This is a peak. This over here is a peak. And this would be in the middle, this is a valley. Okay, so the peaks are called the representative elements. Another name for the representative elements are the group A elements. Boy, that just didn't write right. Okay, so group A elements. Group A is what I'm trying to say there. Okay, because again, at the top, these all have A's on them. These guys over here, too. Remember, the ones in the valley, when you could see the stuff before, were all B's. So sometimes those are called group B elements. Okay? But the representative elements, how'd they get their name? Well, that's probably because they have a little bit of everything on the periodic table. So you can see I have metals, I have these green semimetals over here, okay? I've got nonmetals. I also have gases, these are gases. I have a liquid element, bromine is a liquid element, and then of course I have a whole bunch of solids too. So they represent a little bit of everything out there on the periodic table. Your transition metals are the valleys. So like I said, sometimes they're called group B. Notice hydrogen is not highlighted in this one. Okay, hydrogen's with the group A stuff. So these guys all in the middle, all of these right here, this valley is called the transition metals. Okay. Down at the bottom, these guys are called the inner transition metals. Because, remember I said these squeeze inside the transition metals. They actually squeeze in right there. Okay, so they get called inner transition metals because they are inside the transition metals. Now, some groups have a special name, and we do want to learn those special names. Alkali metals are group 1A. Now, this one's really important. This is hydrogen being weird again. Remember, I said hydrogen is a non-metal. Okay, hydrogen is a non-metal, even though we put it on the left. So it should not be included in the alkali metals. Notice right here, I don't have hydrogen highlighted. So the alkali metals are lithium, potassium, sodium, rubidium, cesium, francium. Okay, and those are the alkali metals only. Hydrogen's not included. It's a trick question I often ask a lot of time on quizzes and tests. This next group here, group 2A, is called the alkaline earth metals. Notice the different spelling on the end. Alkaline earth metals. Alkaline is another word for base, like when we're talking about acids and bases. Okay, so alkaline's another word for base. So when these get mixed in with water, they tend to form a basic solution. You don't really need to know that right now. You're going to learn that later, but it just gives you a little idea about where that name comes from. It's the same thing is true for the alkali metals also. They're in group 1A. They also form bases when put in the water. Okay, so we're going to jump over now to the side. And if you take a look here at group 7A with fluorine, chlorine, bromine, iodine, and astatine, those are your halogens. They are group 7A. Yes, these are the same things that are in like halogen headlights. Okay, your halogens, group 7A. And then over here, group 8A, or on some periodic tables they call it group O, and those are your noble gases. They're called noble gases because they don't like to mix with other elements on the periodic table. So like royalty or nobility, they don't like to mix with the other commoners on the periodic table. So these guys, they're off to the side all by themselves. They too also have some special properties that we'll talk about over the next few weeks. Okay, almost done labeling here. Just a little bit more to do. Okay, this top line at the bottom is called the lanthanides. And the lanthanides begin with lanthanum. And that's right here, it's shaded out. But lanthanum tells you, hey, that's where you go down there. Okay. So those are the lanthanides. The bottom row underneath start with actinium. And so they are called the actinides. Okay. So usually, like I said, those two rows together, they're called the inner transition metals. Sometimes they're called the rare earth elements because they're rare when we dig around in dirt, but they're there. Some of these rare earth elements are becoming really important in your electronics, like iPods and cell phones and things like that. But yeah, if we're just talking about the top row, it's the lanthanides. The bottom row is the actinides. Okay, so let me switch over here real quick to your worksheet. Okay, I'm going to go to your worksheet, and I just want to explain a little bit more before you get started. Okay, so this is what you have down there. Now it says using a periodic table on the reverse side, label, identify, and write a key for the following. So you are going to put all these things on your periodic table. You might want to make little stars or circles for some things, because something's going to be labeled more than once. So some people split boxes, maybe label it half one color, half another color, or put stars or dots in all the representative elements, something like that. But you also need to write a key on that page. You cannot write a key on this page, okay? It has to be done on the periodic table on the other side. So I don't want to be flipping back and forth looking for things. So you write the key on the other side. Now, Mr. Lopez, he has my boxes of colored pencils. He'll pass them down the rows. The boxes are meant to be shared by 3 or 4 people. Okay, you've got a lot of color choices in there. There's not just 10. Okay, there's usually at least 20 in there, multiple blues, things like that. Also, do not use the electric pencil sharpener at the front of the room. It jams on colored pencils. That's why in your colored pencil box you have a sharpener in there. Okay, so this is your assignment to work on for the remainder of the period. Having this done and checked off complete is going to get you two extra anti-procrastination points if you have it done by Friday. Sorry you guys can't use the netbooks today. That's why you don't have science starters, but that gives you plenty of time. You actually get to spend the rest of the class period coloring, so enjoy.